This is Chapter 6, Book 1 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Chapter 6, Far-Reaching Plan. Knowing that the rectification of the Earth's axis was satisfactorily begun, and that each year would show an increasing improvement in climate, many of the delegates, after hearing Bearwarden's speech, set out for their homes. Those from the valley of the Amazon and the eastern coast of South America boarded a lightning express that rushed them to Key West at the rate of 300 miles an hour. The railroad had 6 tracks, 2 for through passengers, 2 for locals, and 2 for freight. 600 feet long by 300 in width, the deck of which was 100 feet above the surface, which carried them over the water at the rate of a mile a minute, around the eastern end of Cuba, through Windward Passage, and so to the South American mainland, where they continued their journey by rail. The Siberian and Russian delegates, who, of course, felt a keen interest in the company's proceedings, took a magnetic double-ender car to Bering Strait. It was 18 feet high, 150 feet long, and had 2 stories. The upper, with a toughened glass dome running the entire length, descended to within 3 feet of the floor, and afforded an unobstructed view of the rushing scenery. The rails on which it ran were 10 feet apart, the wheels being beyond the sides, like those of a carriage, and fitted with ball bearings to ridged axles. The car's flexibility allowed it to follow slight irregularities in the track, while the free, independent wheels gave it a great advantage in rounding curves over cars with wheels and axle in one casting, in which one must slip while traversing a greater or smaller arc than the other, except when the slope of the tread and the centrifugal force happened to correspond exactly. The fact of having its supports outside instead of underneath, while increasing its stability, also enabled the lower floor to come much nearer the ground, while still the wheels were large. Arriving in just 20 hours, they ran across on an electric ferry boat, capable of carrying several dozen cars, to East Cape, Siberia, and then, by running as far north as possible, had a shortcut to Europe. The Patagonians went by the all-rail intercontinental line, without change of cars, making the run of 10,000 miles in 40 hours. The Australians entered a flying machine and were soon out of sight, while the Central Americans and members from other states of the Union returned for the most part in their mechanical phaetons. "A prospective improvement in traveling," said Bearwarden, as he and his friends watched the crowd disperse, "will be when we can rise beyond the limits of the atmosphere, wait till the earth revolves beneath us, and descend in 12 hours on the other side." "True," said Cortlandt, "but then we can travel westward only, and shall have to make a complete circuit when we wish to go east." A few days later there was a knock at President Bearwarden's door, while he was seated at his desk looking over some papers and other matters. Taking his foot from a partly opened desk drawer where it had been resting, he placed it upon the handle of a handsome brass-mounted bellows, which proved to be articulating, for as he pressed, it called lustily, "Come in." The door opened, and in walked Secretary of State Stillman, Secretary of the Navy Deepwaters, who was himself an old sailor, Dr. Cortlandt, Ayrault, Vice President Dumby of the TAS Company, and 2 of the company's directors. "Good morning," said Bearwarden as he shook hands with his friends. "Charmed to see you." "That's a great invention," said Secretary Stillman, examining the bellows. "We must get Congress to make an appropriation for its introduction in the department buildings in Washington. You have no idea how it dries my throat to be all the time shouting, 'Come in!'" "Do you know, Bearwarden," said Secretary Deepwaters, "I'm afraid when we have this millennium of climate everyone will be so well satisfied that our friend here," pointing to Secretary Stillman with his thumb, "will have nothing to do. I have sometimes thought some of the excitement will be gone, and the struggle of the survival of the fittest will become less problematical," said Bearwarden. "The earth seems destined to have a calm old age," said Cortlandt, "unless we can look to the Cabinet to prevent it. This world will soon be a dull place. I wish we could leave it for a change," said Ayrault. "I don't mean forever, of course, but just as people have grown tired of remaining like plants in the places in which they grew. Alan has been a caterpillar for untold ages. Can he not become the butterfly?" "Since we have found out how to straighten the axis," said Deepwaters, "might we not go one better and improve the orbit as well, increase the difference between aphelion and perihelion, and give those that still like a changing climate a chance? While incidentally we should see more of the world, I mean the solar system, and by enlarging the parallax be able to measure the distance of a greater number of fixed stars. Put your helm hard down and shout 'Hard a lee!' You see there is nothing simpler. You keep her off now, and 6 months hence you let her luff." "That's an idea," said Bearwarden. "Our orbit could be enough like that of a comet to cross the orbits of both Venus and Mars, and the climatic extremes would not be inconvenient, the whole earth being simultaneously warmed or cooled. There would be no equinoctials or storms resulting from changes on one part of the surface from intense heat to intense cold. Every part would have a 12-hour day and night, and none would be turned towards or from the sun for 6 months at a time, for however eccentric the orbit, we should keep the axis absolutely straight. At the perihelion there would simply be increased evaporation and clouds near the equator, which would shield those regions from the sun, only to disappear again as the earth receded." "The only trouble," said Cortlandt, "is that we should have no fulcrum. Straightening the axis is simple enough, for we have the attraction of the sun with which to work, and we have but to increase it at one end while decreasing it at the other, and change this as the poles change their inclination towards the sun to bring it about. If a comet with a sufficiently large head would but come along and retard us, or opportunity give us a pull, or if we could increase the attraction of the other planets for us, or decrease it at times, it might be done. If the force, the control of which was discovered too late to help us straighten the axis, could be applied on a sufficiently large scale, if apergy—" "I have it!" exclaimed Ayrault, jumping up. "Apergy will do it. We can build an airtight projectile, hermetically seal ourselves within, and charge it in such a way that it will be repelled by the magnetism of the earth, and it will be forced from it with equal or greater violence than that with which it is ordinarily attracted. I believe the earth has but the same relation to space that the individual molecule has to any solid, liquid, or gaseous matter we know, and that, just as the molecules strive to fly apart on the application of heat, this earth will repel that projectile when electricity, which we are coming to look upon as another form of heat, is properly applied. It must be so, and it is the manifest destiny of the race to improve it. Man is a spirit cursed with a mortal body, which glues him to the earth, and his yearning to rise, which is innate, is, I believe, only a part of his probation and trial." "Show us how it can be done!" shouted his listeners in chorus. "Apergy is and must be able to do it," Ayrault continued. "Throughout nature we find a system of compensation. The centripetal force is offset by the centrifugal, and when, according to the fable, the crystal complained of its hard lot in being unable to move, while the eagle could soar through the upper air and see all the glories of the world, the bird replied, 'My life is but for a moment, while you, set in the rock, will live forever, and will see the last sunrise that flashes upon the earth.' We know that Christ while walking on the waves, did not sink, and that he and Elijah were carried up into the heaven. What became of their material bodies we cannot tell, but they were certainly superior to the force of gravitation. We have no reason to believe that in miracles any natural law was broken, or even set aside, but simply that some other law, whose workings we do not understand, became operative and modified the law that otherwise would have had things its own way. In apergy, we undoubtedly have the counterpart of gravitation, which must exist, or nature's system of compensation is broken. May we not believe that in Christ's transfiguration on the mount, and in the appearance of Moses and Elias with him, doubtless in the flesh, since otherwise mortal eyes could not have seen them, apergy came into play and upheld them; that otherwise, and if no other modification had intervened, they would have fallen to the ground; and that apergy was, in other words, the working principle of those miracles? May we not also believe, added Cortlandt, that in the transfiguration Christ's companions took the substance of their material bodies, the oxygen, hydrogen, nitrogen, and carbon, from the air and the moisture it contained, for though spiritual bodies, be their activity magnetic or any other, could of course pass the absolute cold and void of space without being affected, no mortal body could, and that in the same manner Elijah's body dissolved into air without the usual intervention of decomposition, for we know that, though matter can easily change its form, it can never be destroyed. All assented to this, and Ayrault continued: "If apergy can annul gravitation, I do not see why it should not do more, for to annul it the repulsion of the earth that produces must be as great as its attraction, unless we suppose gravitation for the time being to be suspended, but whether it is or not does not affect the result in this case, for after the apergetic repulsion is brought to the degree at which a body does not fall, any increase in the current's strength will cause it to rise, and in the case of electromagnets we know that the attraction or repulsion has practically no limit. This will be of great advantage to us," he continued, "for if a projectile could move away from the earth with no more rapid acceleration than that with which it approaches, it would take too long to reach the nearest planet, but the maximum repulsion being at the start by reason of its proximity to the earth, for apergy, being the counterpart of gravitation, is subject to Newton's and Kepler's laws, the acceleration of a body apergetically charged will be greatest at first. Two inclined planes may have the same fall, but a ball will reach the bottom of one that is steepest near the top in less time than on any other, because the maximum acceleration is at the start. We are all tired of being stuck to this cosmical speck, with its monotonous ocean, leaden sky, and single moon that is useless more than half the time, while its size is so microscopic compared with the universe that we can traverse its great circle in 4 days. Its possibilities are exhausted, and just as Greece became too small for the civilization of the Greeks, and as reproduction is growth beyond the individual, so it seems to me that the future glory of the human race lies in exploring at least the solar system without waiting to become shades." "Should you propose to go to Mars or Venus?" asked Cortlandt. "No," replied Ayrault. "We know all about Mars. It is but 1/7 the size of Earth, and as the axis is inclined more than ours, it would be a less comfortable globe than this, while, as our president here told us in his T.A.S. Company's report, the axis of Venus is inclined to such a degree that it would be almost uninhabitable for us. It would be as if colonists tried to settle Greenland, or had come to North America during its glacial period. Neither Venus nor Mars would be a good place now." "Where should you propose to go?" asked Stillman. "To Jupiter, and, if possible, after that to Saturn," replied Ayrault. "The former's mean distance from the sun is 480 million miles, but, as our president showed us, its axis is so nearly straight that I think, with its internal warmth, there will be nothing to fear from cold, though, on account of the planet's vast size, objects on its surface weigh more than twice as much as here. If I am able to reach it by means of apergy, the same force will enable me to regulate my weight. Will any one go with me?" "Splendid," said Bearwarden. "If Mr. Dumby, our vice president, will temporarily assume my office, nothing will give me greater pleasure." "So will I go, if there is room for me," said Cortlandt. "I will at once resign my place as government expert, and consider it the grandest event of my life. If I were not afraid of leaving Stillman here to his own devices, I'd ask for a berth as well," said Deepwaters. "I am afraid," said Stillman, "if you take any more, you will be overcrowded." "Modesty forbids his saying," said Deepwaters, "that it wouldn't do for the country to have all its eggs in one basket." "Are you not afraid you will find the surface hot, and even molten?" asked Vice President Dumby. "With its 86,500-mile diameter, the amount of original internal heat must have been terrific." "No," said Cortlandt, "it cannot be molten, or even in the least degree luminous, for if it were, its satellites would be visible when they enter its shadow, whereas they entirely disappear." "I do not believe Jupiter's surface is even perceptibly warm," said Bearwarden. "We know that Algol, known to the ancients as the demon star, and several other variable stars, are accompanied by a dark companion, with which they revolve about a common center, and which periodically obscures part of their light. Now, some of these non-luminaries are nearly as large as our sun, and of course many hundred times the size of Jupiter. If these bodies have lost enough heat to be invisible, Jupiter's surface at least must be nearly cold." "In the phosphorescence of sea water," said Cortlandt, "and in other instances in nature, we find light without heat, and we may soon be able to produce it in the arts by oxidizing coal without the intervention of the steam engine, but we never find any considerable heat without light." "I am convinced," said Bearwarden, "that we shall find Jupiter habitable for intelligent beings who have been developed on a more advanced sphere than itself, though I do not believe it has progressed far enough in its evolution to produce them. I expect to find it in its Paleozoic or Mesozoic period, while over 100 years ago the English astronomer Chambers thought that on Saturn there was good reason for suspecting the presence of snow." "What sort of spaceship do you propose to have?" asked the vice president. "As you have to pass through but little air," said Deepwaters, "I would suggest a short stroke cylinder of large diameter, with a flat base and dome roof, composed of aluminum, or, still better, glucinum, or beryllium, as it is sometimes called, which is twice as good a conductor of electricity as aluminum, 4 times as strong, and is the lightest of all known metals, having a specific gravity of only 2, which last property will be of great use to you, for of course the more weight you have to propel, the more apergetic repulsion you will have to develop." "I will get some drawing paper I left outside in my trap," said Ayrault, "when with your ideas we may arrive at something definite," saying which he left the room. "He seems very cynical in his ideas of life and the world in general," said Secretary Stillman, "for a man of his age, and one that is engaged." "You see," replied Bearwarden, "his fiancee is not yet a senior, being in the class of 2001 at Vassar, and so cannot marry him for a year. Not till next June can this sweet girl graduate come forth with her mortar board and sheepskin to enlighten the world and make him happy. That is, I suspect, one reason why he proposed this trip. This is the end of Chapter 6 in Book 1 of A Journey in Other Worlds. Recording by Tom Weiss. This is Chapter 7, Book 1 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Chapter 7, Hard at Work. In a few moments, Ayrault returned with pencils, a pair of compasses, and paper. "Let us see, in the first place," said Deepwaters, "how long the journey will take. Since a stone falls 16.09 feet the first second, and 64 plus feet the next, it is easy to calculate at what rate your speed would increase with a repulsion twice that of the ordinary traction, but I think this would be too slow. It will be best to treble or quadruple the apergetic charge, which can easily be done, in which case your speed will exceed the muzzle velocity of a projectile from a long-range gun in a few seconds. As the Earth's repulsion decreases, the attraction of Mars and Jupiter will increase, and, there being no resistance, your gait will become more and more rapid till it is necessary to reverse the charge to avoid being dashed to pieces or being consumed like a falling star by the friction in passing through Jupiter's atmosphere. You can be on the safe side by checking your speed in advance. You must, of course, be careful to avoid collisions with meteors and asteroids, but if you do, they will be of use to you, for by attracting or repelling them you can change your course to suit yourself, and also theirs in inverse ratio to their masses. Jupiter's moons will be like head and stern lines, in enabling you to choose the part of the surface on which you wish to land. With apergy, it is as essential to have some very heavy body on which to work, within range, as to have water about a ship's propellers. Whether, when apergy is developed, gravitation is temporarily annulled or reversed like the late attraction of a magnet when the current is changed, or whether it is merely overpowered, in which case your motion will be the resultant of the two, is an unsettled and not very important point. For though we know but little more of the nature of electricity than was known 100 years ago, this does not prevent our producing and using it. Jupiter, when in opposition," he continued, "is about 380 million miles from us, and it takes light, which travels at the rate of 190,000 miles a second, just 34 minutes to reach the earth from Jupiter. If we suppose the average speed of your ship to be 1/500th as great, it will take you just 11 days, 19 hours, and 20 minutes to make the journey. You will have a fine view of Mars and the asteroids, and when 1,169,000 miles from Jupiter, will cross the orbit of Callisto, the fifth moon in distance from the giant planet. That will be your best point to steer by." "I think," said Ayrault, "as that will be the first member of Jupiter's system we pass, and as it will guide us into port, it would be a good name for our ship, and you must christen her if we have her launched." "No, no," said Deepwaters, "Miss Preston must do that, but we certainly should have a launch, for you might have to land in the water, and you must be sure the ship is tight." "Talking of tight ships," said Bearwarden, passing a decanter of claret to Stillman, "may remind us that it is time to splice the main brace. There's a bottle of whiskey and some water just behind you," he added to Deepwaters, "while 3 minutes after I ring this bell," he said, pressing a button and jerking a handle marked 8, "the champagne cocktails will be on the desk." "I see you know his ways," said Stillman to Bearwarden, drooping his eyes in Deepwaters' direction. "Oh, yes, I've been here before," replied Deepwaters. "You see, We Navy men have to hustle nowadays, and can't pass our time in a high-backed chair, talking platitudes." At this moment there was a slight rumbling, and 8 champagne cocktails, with the froth still on, and straws on a separate plate, shot in and landed on a corner of the desk. "Help yourselves, gentlemen," said Bearwarden, placing them on a table. "I hope we shall find them cold." "Do you know," said Deepwaters to Ayrault, while rapidly making his cocktail disappear, "the Callisto's cost with its outfit will be very great, especially if you use glucinum, which, though the ideal metal for the purpose, comes pretty high? I suggest that you apply to Congress for an appropriation. This experiment comes under the Promotion of Science Act, and any bill for it would certainly pass." "No, indeed," replied Ayrault. "The Callisto trip will be a privilege and glory I would not miss, and building her will be a part of it. I shall put in everything conducive to success, but will come to the government only for advice." "I will send a letter to all our ambassadors and consuls," said Stillman, "to telegraph the department anything they may know or learn that will be of use in adjusting the batteries, controlling the machine, or anything else, and will turn over to you in a succinct form all information that may be relevant, for without much sorting you would be overwhelmed." "And I," said Deepwaters, "will order the commanders of our vessels to give you a farewell salute at starting, and to pick you up in case you fail. When you have demonstrated the suitability of apergy," he continued, "and the habitability of Jupiter and Saturn, which with their 5 and 8 moons respectively, and rings thrown in, must both be vastly superior to our little second-rate globe, we will see what can be done towards changing our orbit, and if we cannot swing a little nearer to our new world or worlds. Then we'll lower, or rather raise, the boats in the shape of numerous Callistos, and have a landing party ready at each opposition, while a man or two can be placed in charge of each projectile to bring it back in ballast. Thus we may soon have regular interplanetary lines." "As every place seems to have been settled for some other," said Cortlandt, "I do not see why, with increased scientific facilities, history should not repeat itself, and this be the point from which to colonize the solar system. For the present at least, it would seem that we could not get beyond that." "As it would be quite an undertaking to change the orbit," said Deepwaters, "we shall have time, meanwhile, to absorb or run out all inferior races, so that we shall not make the mistake of extending the Tower of Babel." "He is putting on his war paint," said Stillman, "and will soon want a planet to himself." "I see no necessity for even changing the orbit," said Bearwarden, "except for the benefit of those that remain. If this attempt succeeds, it can doubtless be repeated. An increase in eccentricity would merely shorten the journey, if aphelion always coincided with opposition, which it would not." "Let us know how you are getting on," said Deepwaters to Ayrault, "and be sure you have the Callisto properly christened. Step lively there, landlubbers," he called to Stillman. "I have an appointment at Washington at 1, and it is now 20 minutes past 12." Ayrault immediately advertised for bids for the construction of a glucinum cylinder 25 feet in diameter, 15 feet high at the sides, with a domed roof, bringing up the total height to 21 feet, and with a small gutter about it to catch the rain on Jupiter or any other planet they might visit. The sides, roof, and floor were to consist of 2 sheets, each 1/3 of an inch thick and 6 inches apart, the space between to be filled with mineral wool, as a protection against the intense cold of space. There were also to be several keels and supports underneath, on which the car should rest. Large toughened plate glass windows were to be let into the roof and sides, and smaller ones in the floor, all to be furnished with thick shades and curtains. Ayrault also decided to have it divided into 2 stories, with ceilings 6 1/2 to 7.5 feet high, respectively, with a sort of crow's nest or observatory at the top, the floors to be lattice work like those in the engine room of a steamer, so that when the carpets were rolled up they should not greatly obstruct the view. The wide flat base and the low center of gravity would, he saw, be of use in withstanding the high winds that he knew often prevailed on Jupiter. As soon as possible he awarded the contract, and then, entering his smart electric trap, steered for Vassar University along what was the old post road, though its builders would not have recognized it with its asphalt surface, straightened curves, and easy grades, to ask his idol to christen the Callisto when it should be finished. Starting from the upper end of Central Park, he stopped to buy her a bunch of violets, and then ran to Poughkeepsie in 2 hours. Sylvia Preston was a lovely girl, with blue eyes, brown hair, and perfect figure, clear white skin, and just 20. She was delighted to see him, and said she would love to christen the Callisto, or do anything else that he wished. "But I am so sorry you are going away," she went on, "and we shall not even be able to write." "Why couldn't we be married now," he asked, "and go to Jupiter for our honeymoon?" "I'm afraid, dear," she answered, "you would be sorry a few years hence if I didn't take my degree, and, besides, as you have asked those other men, there wouldn't be room for me." "We could have made other arrangements," he replied, "had I been able to persuade you to go." "Won't you dine with us at Delmonico's this evening, and go to the play?" she asked. "Papa has taken a box." "Of course I will," he said, brightening up. "What are you going to wear?" "Oh, I suppose something light and cool, for it's so hot," she answered. "I'll go now, so as to be ready," he said, getting up and going towards the door, to which Sylvia followed him. A man in livery stood at the step of the phaeton. Ayrault got in and turned on the current, and his man climbed up behind. On turning into the main road, Ayrault was about to increase his speed when Sylvia, who had taken a short cut, appeared at the wayside, carrying her hat in one hand and her gloves in the other. "I couldn't let you go all by yourself," she said. "The fact is, I wanted to be with you." "You are the sweetest thing that ever lived, and I'll love you all my days," he said, getting down and helping Sylvia to the seat beside him. "What a nuisance this fellow behind is," he continued, referring to the groom, "for, though he is a Russian and speaks but little English, it is unpleasant to feel he is there." "You'll have to write your sweet nothings, instead of saying them," Sylvia replied. "For you to leave around for the other girls to see?" answered Ayrault with a smile. "I don't know what your other girls do," she returned, "but with me you are safe." Ayrault fairly made his phaeton spin, going up the grades like a shot and down like a bird. On reaching New York, he left Sylvia at her house, then ran his machine to a florist's, where he ordered some lilies and roses, and then steered his way to his club, where he dressed for dinner. Shortly before the time he repaired to Delmonico's, which name had become historical, though the founders themselves were long dead, and sat guard at a table till Sylvia, wearing his flowers and looking more beautiful than any of them, arrived with her mother and father, and Bearwarden, whom they knew very well. "How are the exams getting on, Miss Preston?" Bearwarden asked. "Pretty well," she replied with a smile. "We had English literature yesterday, and natural history the day before. Next week we have chemistry and philosophy." "What are you taking in natural history?" asked Bearwarden, with interest. "Oh, principally physical geography, geology, and meteorology," she replied. "I think them entrancing." "It must be a consolation," said Ayrault, "when your best hat is spoiled by rain, to know the reason why. Your average," he continued, addressing Sylvia, "was 90 in the semi annuals, and I haven't a doubt that the finals will maintain your record for the year." "Don't be too sure," she replied. "I have been loafing awfully, and had to engage a grind as a coach." After dinner they went to the play, where they saw a presentation of society at the close of the 20th century, which Sylvia and Ayrault enjoyed immensely. A few days after the Delmonico dinner, while Bearwarden, Cortlandt, and Ayrault sat together discussing their plans, the servant announced Ayrault's family physician, Dr. Tubercle Germany, who had been requested to call. "Delighted to see you, Doctor," said Ayrault, shaking hands. "You know Colonel Bearwarden, our president, and Dr. Cortlandt, an LL.D., however, and not a medico." "I have had the pleasure," replied Dr. Germany, shaking hands with both. "As you may be aware, Doctor," said Ayrault, when they were seated, "we are about to take a short trip to Jupiter, and, if time allows, to Saturn. We have come to you, as one familiar with every known germ, for a few precautionary suggestions and advice concerning our medicine chest." "Indeed," replied Dr. Germany, "a thorough knowledge of bacteriology is the groundwork of therapeutics. It is practically admitted that every ailment, with the exception of mechanical injuries, is the direct result of a specific germ, and even in accidents and simple fractures, no matter what may be the nature of the bruise, a micro organism soon announces its presence, so that if not the parent, it is the inseparable companion, in fact, the shadow of disease. Now, though not the first cause in this instance, it has been indubitably proved that much of the effect, the fever and pain, are produced and continued by the active, omnipresent, sleepless sperm. Either kill the monococcus or heal the wound, and you are free from both. It being therefore granted that the ills of life are in the air, we have but to find the peculiar nature of the case in hand, its habits, tastes, and constitution, in order to destroy it. Impoverish the soil on which it thrives before its arrival, if you can foresee the nature of the inoculation to which you will be exposed, by a dilute solution of itself, and supply it only with what it particularly dislikes. For an already established tubercle, requiring rapid action of the blood, such as may well exist among the birds and vertebrates of Jupiter and Saturn, I suggest a hypodermic rattlesnake injection, while hydrocyanic acid and tarantula saliva may also come in well. The combinations that so long destroyed us have already become our panacea." "I see you have these poisons at your fingers' ends," said Ayrault, "and we shall feel the utmost confidence in the remedies and directions you prescribed." They found that, in addition to their medicine chest, they would have to make room for the following articles, and also many more: 6 shotguns, 3 double-barreled 12 bores, 3 magazine 10 bores, 3 rifles, 3 revolvers, a large supply of ammunition, explosive and solid balls, hunting knives, fishing tackle, compass, sextant, geometrical instruments, canned food for 40 days, appliance for renewing air, clothing, rubber boots, apergetic apparatus, protection wires, aneromic barometer, and kodaks. This is the end of Chapter 7 in Book 1 of A Journey in Other Worlds. Recording by Tom Weiss. This is Chapter 8, Book 1 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Chapter 8. Goodbye. At last the preparations were completed, and it was arranged that the Callisto should begin its journey at 11 o'clock a.m., December 21st, the Northern Hemisphere's shortest day. Though 6 months' operation could hardly be expected to have produced much change in the inclination of the earth's axis, the autumn held on wonderfully, and December was pronounced very mild. Fully 1,000,000 people were in and about Van Cortlandt Park hours before the time announced for the start, and those near looked inquiringly at the trim little airship that, having done well on the trial trip, rested on her longitudinal and transverse keels, with a battery of chemicals alongside, to make sure of a full power supply. The President and his cabinet, including, of course, the shining lights of the State and Navy Departments, came from Washington. These, together with Mr. and Mrs. Preston, and a number of people with passes, occupied seats arranged at the sides of the platform, while sightseers and scientists assembled from every part of the world. "There's a ship for you," said Secretary Stillman to the Secretary of the Navy. "She'll not have to be dry docked for barnacles, neither will the least breeze make the passengers sick." "That's all you landlubbers think of," replied Deepwaters. "I remember one of the kings over in Europe said to me, as he introduced me to the Queen, 'Your Secretary of State is a great man, but why does he always part his hair in the middle?' 'So that it shall not turn his head,' I replied. 'But with so gallant and handsome an officer as you to lean upon,' he answered, 'I should think he could look down on all the world.' Whereupon I asked him what he'd take to drink." "Your apology is accepted," replied Secretary Stillman. Cortlandt also came from Washington, where, as chief of the government's expert examiners board, he had temporary quarters. Bearwarden sailed over the spectators' heads in one of the Terrestrial Axis Straightening Company's flying machines, while Ayrault, to avoid the crowd, had come to the Callisto early, and was showing the interior arrangements to Sylvia, who had accompanied him. She was somewhat piqued because at the last moment he had not absolutely insisted on carrying her off, or offered, if necessary, to displace his presidential and Doctor of Laws friends in order to make room. "You will have an ideal trip," she said, looking over some astronomical star charts and photographic maps of Jupiter and Saturn that lay on the table, with a pair of compasses, "and I hope you won't lose your way." "I shall need no compass to find my way back," replied Ayrault. "If I ever succeeded in leaving this planet, neither will star charts be necessary, for you will be a magnet stronger than any compass, and, compared with my star, all others are dim." "You should write a book," said Sylvia, "and put some of those things in it." She was wearing a bunch of forget-me-nots, and violets that she had cut from a small flower garden of potted plants Ayrault had sent her, which she had placed in her father's conservatory. At this moment the small chime clock set in the Callisto's woodwork rang out 11:15. As the sounds died away, Sylvia became very pale, and she began to regret, in her womanly way, that she had allowed her hero to attempt this experiment. "Oh," she said, clinging to his arm, "it was very wrong of me to let you begin this. I was so dazzled by the splendor of your scheme when I heard it, and so anxious that you should have the glory of being the first to surpass Columbus, that I did not realize the full meaning. I thought, also, you seemed rather ready to leave me," she added gently, "and so said little. You do not know how it almost breaks my heart, now that I am about to lose you. It was quixotic to let you undertake this journey." "An undertaker would have given me his kind offices for one even longer, had I remained here," replied Ayrault. "I cannot live in this humdrum world without you. The most sustained excitement cannot even palliate what seems to me like unrequited love." "Oh, Dick," she exclaimed, giving him a reproachful glance, "you mustn't say that. You know you have often told me my reason for staying and taking my degree was good. My lot will be very much harder than yours, for you will forget me in the excitement of discovery and adventure. But what can I do in the midst of all the old associations?" "Never mind, sweetheart," he said, kissing her hand. "I have seemed on the verge of despair all the time." Seeing that their separation must shortly begin, Ayrault tried to assume a cheerful look, but as Sylvia turned her eyes away they were suspiciously moist. Just 1 minute before the starting time, Ayrault took Sylvia back to her mother, and, after pressing her hand, and having one last long look into her, or as he considered them, his deep sea eyes, he returned to the Callisto, and was standing at the foot of the telescopic aluminum ladder when his friends arrived. As all baggage and impedimenta had been sent aboard and properly stowed the day before, the travellers had naught to do but climb to and enter by the second-story window. It distressed Bearwarden that the North Pole's exact declination on the 21st day of December, when the axis was most inclined, could not be figured out by the hour at which they were to start, so as to show what change, if any, had already been brought about, but the astronomers were working industriously, and promised that, if it were finished by midnight, they would telegraph the result into space by flashlight code. Raising his hat to his fiancée and his prospective parents-in-law, Ayrault followed them up. To draw in and fold the ladder was but the work of a moment. As the clocks in the neighbouring steeples began to strike 11, Ayrault touched the switch that would correspond to the throttle of an engine, and the motors began to work at rapidly increasing speed. Slowly the Callisto left her resting place, as a Galatea might her pedestal, only, instead of coming down, she rose still higher. A large American flag hanging from the window, which, as they started, fluttered as in a southern zephyr, soon began to flap as in a stiff breeze as the car's speed increased. With a final wave, at which a battery of 21 field pieces made the air ring with a salute, and the multitude raised a mighty cheer, they drew it in and closed the window, sealing it hermetically in order to keep in the air that, had an opening remained, would soon have become rarefied. Sylvia had waved her handkerchief with the utmost enthusiasm, in spite of the sadness at her heart, but she now had other use for it in trying to hide her tears. The Callisto was still going straight up, with a speed already as great as a cannon ball's, and was almost out of sight. The multitude then began to disperse, and Sylvia returned to her home. Let us now follow the Callisto. The Earth and Jupiter not being exactly in opposition, as they would be if the sun, the earth, and Jupiter were in line, with the earth between the two, but rather as shown in the diagram, the Callisto's journey was considerably more than the 380 million miles, the mean opposition distance. As they wished to start by daylight, i.e., from the side of the earth turned towards the sun, they could not steer immediately for Jupiter, but were obliged to go a few hundred miles in the direction of the sun, then change their course to something like a tangent to the earth, and get their final right direction in swinging near the moon, since they must be comparatively near some material object to bring apergy into play. The maximum power being turned on, the projectiles shot from the earth with tremendous and rapidly increasing speed by the shortest course, i.e., a straight line, so that for the present it was not necessary to steer. Until beyond the limits of the atmosphere, they kept the greatest apergetic repulsion focused on the upper part of their cylinder, so that its point went first, and they encountered least possible resistance. Looking through the floor windows, therefore, the travellers had a most superb view. The air being clear, the eastern border of North America and the Atlantic were outlined as on a map, the blue of the ocean and brownish colour of the land, with white snow, patches on the elevations being very marked. The Hudson and the Sound appeared as clearly defined blue ribbons, and between and around the two they could see New York. They also saw the ocean, dotted for miles, with points in which they recognized the marine spiders and cruisers of the North Atlantic Squadron, and the ships on the home station, which they knew were watching them through their glasses. "I see," said Cortlandt, "that Deepwaters has been as good as his word, and has his ships on the watch to rescue us in case we fail." "Yes," replied Bearwarden, "he is the right sort. When he gave that promise, I knew his men would be there." They soon perceived that they had reached the void of space, for though the sun blazed with a splendour they had never before seen, the firmament was intensely black, and the stars shone as at midnight. Here they began to change their course to a curve beginning with a spiral, by charging the Callisto apergetically, and directing the current towards the moon, to act as an aid to the lunar attraction, while still allowing the earth to repel, and their motion gradually became the resultant of the two forces, the change from a straight line being so gradual, however, that for some minutes they scarcely perceived it. The coronal streamers about the sun, such as are visible on earth during a total eclipse, shone with a halo against the ultra-Cimmerian background, bursting forth to a height of 20 or 30,000 miles above the surface in vast cyclonic storms, producing so rapid a motion that a column of incandescent gas may move 10,000 miles in less than 10 minutes. Whether these great streaks were in part electrical phenomena similar to the aurora borealis, or entirely of intensely heated material thrown up by explosions within the sun's mass, they could not tell even from their point of vantage. "I believe," said Cortlandt, pointing to the streamers, "that they are masses of gas thrown beyond the sun's atmosphere, which expands enormously when the pressure to which they are subjected in the sun is removed, for only in space, freed from resistance, could they move at such velocities, and that their brilliance is increased by great electrical disturbance. If they were entirely the play of electrical forces, their change of place would be practically instantaneous, which, however rapid their movement, is not the case." This is the end of Chapter 8 in Book 1 of A Journey in Other Worlds. Recording by Tom Weiss. This is Chapter 1, Book 2 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Book 2, Chapter 1, The Last of the Earth. Finding that they were rapidly swinging towards their proper course, and that the earth in its journey about the sun would move out of their way, they divided their power between repelling the body they had left and increasing the attraction of the moon, and then set about getting their house in order. Bearwarden, having the largest appetite, was elected cook, the others sagely divining that labour so largely for himself would be no trial. Their small but businesslike looking electric range was therefore soon in full blast, with Bearwarden in command. It had enough current to provide heat for cooking for 400 hours, which was an ample margin, and it had this advantage, that no matter how much it was used, it could not exhaust the air as any other form of heat would. There were also a number of 16 candle power incandescent lamps, so that when passing through the shadow of a planet, or at night after their arrival on Jupiter, their car would be brightly illuminated. They had also a good searchlight for examining the dark side of a satellite, or exploring the spaces in Saturn's rings. Having lunched sumptuously on canned chicken soup, beef a la jardiniere, and pheasant that had been sent them by some of their admirers that morning, they put the bones and the glass can that had contained the soup into the double-doored partition or vestibule, placing a large sheet of cardboard to act as a wad between the scraps and the outside door. By pressing a button, they unfastened the outside door, and the articles to be disposed of were shot off by the expansion of the air between the cardboard disk and the inside door, after which the outside door was drawn back to its place by a current sent through a magnet, but little power being required to reclose it with no resisting atmospheric pressure. As the electricity ran along a wire passing through a hermetically sealed opening in the floor, there was no way by which more air than that in the vestibules could escape, and as the somewhat flat space between the doors contained less than 1 cubic foot, the air pressure inside the Callisto could not be materially lessened by a few openings. "By filling the vestibule as full as possible," said Bearwarden, "and so displacing most of its air, we should be able to open the outside door oftener without danger of rarefaction." The things they had discharged flew off with considerable speed, and were soon out of sight, but it was not necessary for them to move fast, provided they moved at all, for the resistance being nil, they would be sure to go beyond the range of vision, provided enough time was allowed, even if the Callisto's speed was not being increased by apergy, in which case articles outside and not affected would be quickly left behind. The earth, which at first had filled nearly half their sky, was rapidly growing smaller. Being almost between themselves and the sun, it looked like a crescent moon, and when it was only about 20 times the size of the moon, they calculated that they must have come nearly 200,000 miles. The moon was now on what a sailor would call the starboard bow, i.e., to the right and ahead. Being a little more than 3/4 full, and only about 50,000 miles off, it presented a splendid sight, brilliant as polished silver, and about 25 times as large as they had ever before seen it with the unaided eye. It was just 10 hours since they had started, and at that moment 9 a.m. in New York, but, though it was night there, the Callisto was bathed in a flood of sunlight such as never shines on earth. The night they would have was on the side of the Callisto turned away from the sun, unless they passed through some shadow which they intended to avoid, on account of the danger of colliding with a meteor in the dark. The moon and the Callisto were moving on converging lines, the curve on which they had entered having swung them to the side nearest the earth. But they saw that their own tremendous and increasing speed would carry them in front of the moon in its nearly circular orbit. Wishing to change the direction of their flight by the moon's attraction, they shut off the power driving them from the earth, whereupon the Callisto turned its heavy base towards the moon. They were already moving at such speed that their momentum alone would carry them hundreds of thousands of miles into space, and were then almost abreast of the earth's satellite, which was but a few thousand miles away. The spectacle was magnificent. As they looked at it through their field glasses or with the unaided eye, the great cracks and craters showed with the utmost clearness, sweeping past them almost as the landscape flies past a railway train. There was something awe-inspiring in the vast antiquity of that furrowed lunar surface, by far the oldest thing that mortal eye can see, since, while observing the ceaseless political or geological changes on earth, the face of this dead satellite, on account of the absence of air and water and consequent erosion, has remained unchanged for bygone ages, as it doubtless will for many more. They closely watched the Callisto's course. At first it did not seem to deflect from a straight line, and they stood ready to turn on the apergetic force again, when the car very slowly began to show the effect of the moon's near pull, but not till they had so far passed it that the dark side was towards them were they heading straight for Jupiter. Then they again turned on full power, and got a send-off shove on the moon and earth combined, which increased their speed so rapidly that they felt they could soon shut off the current altogether and save their supply. "We must be ready to watch the signals from the Arctic Circle," said Bearwarden. "At midnight, if the calculations are finished, the result will be flashed by the searchlight." It was then 10 minutes to 12, and the earth was already over 400,000 miles away. Focusing their glasses upon the region near the North Pole, which, being turned from the sun, was towards them, and in darkness, they waited. "In this blaze of sunlight," said Cortlandt, "I am afraid we can see nothing." Fortunately, at this moment, the Callisto entered the moon's tapering shadow. "This," said Ayrault, "is good luck. We could, of course, have gone into the shadow, but to change our course would have delayed us, and we might have lost part of the chance of increasing our speed." "There will be no danger from meteors or subsatellites here," said Bearwarden, "for anything revolving about the moon at this distance would be caught by the earth." The sun had apparently set behind the moon, and they were eclipsed. The stars shone with the utmost splendour against the dead black sky, and the earth appeared as a large crescent, still considerably larger than the satellite to which they were accustomed. Exactly at midnight, a faint phosphorescent light, like that of a glow worm, appeared in the region of Greenland on the planet they had left. It gradually increased its strength till it shone like a long white beam projected from a lighthouse, and in this they beheld the work of the greatest searchlight ever made by man, receiving for a few moments all the electricity generated by the available dynamos at Niagara and the Bay of Fundy, the steam engines, and other sources of power in the northern hemisphere. The beam lasted, with growing intensity, for 1 minute. It then spelled out, with clear-cut intervals, according to the cable code, 23 at number 6. "The southern hemisphere pumps are now rising and storing water at full ballast. We have already begun to lower the Atlantic Ocean." "Victory!" shouted Bearwarden in an ecstasy of delight. "Nearly half a degree in 6 months, with but one pole working. If we can add at this rate each time to the speed of straightening already acquired, we can reverse our engines in 5 years, and in 5 more the earth will be at rest and right." "Look," said Ayrault, "they are sending something else." The flashes came in rapid succession, reaching far into space. With their glasses fixed upon them, they made out these sentences: "Our telescopes, in whatever part of the earth was turned towards you, have followed you since you started, and did not lose sight of you till you entered the moon's shadow. On your present course, you will be in darkness until 12:16, when we shall see you again." On receiving this last earthly message, the travellers sprang to their searchlight, and, using its full power, telegraphed back the following: "Many thanks to you for good news about Earth, and to Secretary Deepwaters for lending us the navy. Result of work most glorious. Remember us to everybody. Shadow's edge approaching." This was read by the men in the great observatories, who evidently telephoned it to the Arctic signal light immediately, for it flashed back: "Got your message perfectly. Wish you greatest luck. The T.A.S. Company has decked the Callisto's pedestal with flowers, and has ordered a tablet set up on the site to commemorate your celestial journey." At that moment the shadow swept by, and they were in the full blaze of cloudless sky. The change was so great that for a moment they were obliged to close their eyes. The polished sides of the Callisto shone so brightly that they knew they were easily seen. The power temporarily diverted in sending them the message then returned to the work of draining the Arctic Ocean, which, as the North Pole was now returning to the sun, was the thing to do, and the travelers resumed their study of the heavenly bodies. This is the end of Chapter 1 in Book 2 of A Journey in Other Worlds. Recording by Tom Weiss. Chapter 2, Book 2 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds, Book 2, Chapter 2, Space and Mars. Never before had the travelers observed the stars and planets under such favorable conditions. No air or clouds intervened, and as the Callisto did not revolve on its axis, there was no necessity for changing the direction of the glasses. After an hour of this interesting work, however, as it was already late at the longitude they had left on earth, and as they knew they had many days in space before them, they prepared to go to bed. When ready, they had only to pull down the shades, for as apergy was not applied to them, but only to the Callisto, they still looked upon the floor as down, and closed the heavy curtains to have night or darkness. They found that the side of the Callisto turned constantly towards the sun was becoming very warm, the double toughened glass windows making it like a greenhouse. But they consoled themselves with the thought that the sun's power on them was hourly becoming less, and they felt sure the double walls and thick upholstery would protect them almost anywhere within the solar system from the intense cold of space. "We could easily have arranged," said Ayrault, "for night and day on alternate sides of the Callisto by having strips of metal arranged spirally on the outside, as on the end of an arrow. These would have started us turning as slowly as we liked, since we passed through the atmosphere at a comparatively low rate of speed." "I am afraid," said Cortlandt, "the motion, however slow, would have made us dizzy. It would be confusing to see the heavens turning about us, and it would interfere with using the glasses." The base and one side of the Callisto had constant sunshine, while the other side and the dome were in the blackest night. This dome, on account of its shape, sky windows, and the completeness with which it could be isolated, was an ideal observatory, and there was seldom a time during their waking hours for the rest of the journey when it was not occupied by one, two, or all the observers. "This is something marvellous," said Cortlandt, "about the condition of space. Its absolute cold is appalling, apparently because there is nothing to absorb heat. Yet we find the base of this material projectile uncomfortably warm, though, should we expose a thermometer in the shade in front, we know it would show a temperature of 300 to 400 degrees below zero, were the instrument capable of recording it." Artificial darkness having been obtained, the travellers were soon asleep, Bearwarden's dreams being regaled with thoughts of his company's triumph, Ayrault's, naturally, with visions of Sylvia, while Cortlandt frequently started up, thinking he had already made some great astronomical discovery. About 9 a.m., according to 75th meridian time, the explorers awoke feeling greatly refreshed. The tank in which the liquefied oxygen was kept automatically gave off its gas so evenly that the air remained normal, while the lime contained in cups absorbed the carbon dioxide as fast as they exhaled it. They had darkened those windows through which the sun was actually pouring, for, on account of the emptiness of the surrounding ether and consequent absence of diffusion of light, nothing but the inky blackness of space and the bright stars looked in at the rest. On raising the shades, they got an idea of their speed. A small crescent, smaller than the familiar moon, accompanied by one still tinier, was all that could be seen of the earth and its satellite. "We must," said Bearwarden, "be moving at the rate of nearly 1,000,000 miles an hour, from the way we have travelled." "We must be doing fully 1,000,000," replied Cortlandt, "for by this time we are pretty well in motion, having got a tremendous start when so near the moon, with it and the earth in line." By steering straight for Jupiter, instead of for the place it would occupy 10 days later, they knew they would swing past, for the giant planet, being in rapid motion, would advance; but they did not object to this, since it would give them a chance to examine their new world, in case they wished to do so before alighting; while, if they preferred to land at once, they could easily change their course by means of the moons, the fourth, from which their car was named, being the one that they knew would be of most use. Their tremendous speed showed them that they should have time for exploration on their arrival, and that they would reach their destination sooner than they had expected. The apergetic force being applied, as we have seen, only to the Callisto, just as power in starting is exerted on a carriage or railway car, and only through its passengers, Ayrault and his companions had no unusual sensation except loss of weight, for, when they were so far from the earth, its attraction was very slight, and no other planet was near enough to take its place. After breakfast, wishing to reach the dome, and realizing it would be unnecessary to climb, each in turn gave a slight spring, and was obliged to put up his hands to avoid striking the roof. In the cool quiet of the dark dome, it was difficult to believe that only 20 feet away the sun was shining with such intensity upon the metal base as to make it too hot on the inside to touch without gloves. The first thing that attracted their attention was the size and brilliance of Mars. Although this red planet was over 40,000,000 miles from the earth when they started, they calculated that it was less than 30,000,000 miles from them now, or 5,000,000 miles nearer than it had ever been to them before. This reduction in distance, and the clearness of the void through which they saw it, made it a splendid sight, its disk showing clearly. From hour to hour its size and brightness increased, till towards evening it looked like a small, full moon, the sun shining squarely upon it. They calculated that on the course they were moving they should pass about 900,000 miles to the right or behind it, since it was moving towards their left. They were interested to see what effect the mass of Mars would have on the Callisto, and saw here a chance of still further increasing their speed. Notwithstanding its tremendous rate, they expected to see the Callisto swerve from its straight line and move towards Mars, whose orbital speed of 900 miles a minute they thought would take it out of the Callisto's way, so that no actual collision would occur, even if their airship were left to her own devices. Towards evening, they noticed through their glasses that several apparently island peaks in the southern hemisphere, which was turned towards them, became white, from which they concluded that a snowstorm was in progress. The southern polar region was also markedly glaciated, though the ice cap was not as extensive as either of those at the poles of the earth. "As the Martian winters must be fully as severe as ours," said Cortlandt, "on account of their length, the planet's distance from the sun, and the 27.5 degrees inclination of its axis, we can account for the smallness of its ice caps only by the fact that its oceans cover but 1/4 of its surface instead of 3/4, as on the earth, and there is, consequently, a smaller evaporation and rain and snowfall." They were too much interested to think of sleeping that night, and so, after dining comfortably, returned to their observatory. When within 4,000,000 miles of Mars, the Callisto began to swerve perceptibly, its curve, as when near the moon, beginning with a spiral. They swung on unconcernedly, however, knowing they could check their approach at any time. Soon Mars appeared to have a diameter 10 times as great as that of the moon, and promised shortly to occupy almost one side of their sky. "We must be on the lookout for the satellites," said Cortlandt. "A collision with either would be worse than a wreck on a desert island." They therefore turned their glasses in the direction of the satellites. "Until Professor Hall, at Washington, discovered the two satellites in 1877," he continued, "Mars was supposed to be without moons. The outer one, Deimos, is but 6 miles in diameter, and revolves about its primary in 30 hours and 18 minutes, at a distance of 14,600 miles. As it takes but little longer to complete a revolution than Mars does to rotate on its axis, it remains in the Martial sky 132 hours between rising and setting, passing through all the phases from new moon to full and back again 4 times. That is, it swings 4 times around Mars before going below the horizon. It is one of the smallest bodies discovered with a telescope. The inner one, Phobos, is considerably larger, having a diameter of about 20 miles. It is but 2,700 miles from Mars' surface, and completes its revolution in 7 hours and 38 minutes, which is shorter than any other known period, Jupiter's nearest moon being the next, with 11 hours and 59 minutes. It thus revolves in less than a third of the time Mars takes to rotate, and must consequently rise in the west and set in the east, as it is continually running ahead of the surface of the planet, though the sun and all the other stars rise and set on Mars in the same way as on the earth. When about 15,000 miles from Mars, they sighted Deimos directly ahead, and saw that they should pass on its left, i.e., behind, for it was moving across them. The sun poured directly upon it, making it appear full, and showing all its features. There were small unevennesses on the surface, apparently 70 or 100 feet high, which were the nearest approach to mountains, and they ran in ridges or chains. There were also unmistakable signs of volcanic action, the craters being large compared with the size of the planet, but shallow. They saw no signs of water, and the blackness of the shadows convinced them there was no air. They secured 2 instantaneous photographs of the little satellite as the Callisto swept by, and resumed their inspection of Mars. They noticed red and brownish patches on the peaks that had the morning turned white, from which they concluded that the snow had begun to melt under the warm spring sun. This strengthened the belief they had already formed that on account of its 27½ degrees inclination, the changes in temperature on Mars must be great and sudden. So interested were they with this that they did not at first see a large and bright body moving rapidly on a course that converged with theirs. "We must be ready to repel boarders," said Bearwarden, observing it for the first time, and fixing his glass upon it. "That must be Phobos." Not 10 miles off they beheld Mars' inner moon, and though their own speed caused them to overtake and rush by it like a whirlwind, the satellite's rapid motion in its orbit, in a course temporarily almost parallel with theirs, served to give them a chance to better examine it. Here the mountain ranges were considerably more conspicuous than on Deimos, and there were boulders and loose stones upon their slopes, which looked as if there might at some time have been frost and water on its surface. But it was all dry now, neither was there any air. The evidences of volcanic action were also plainly visible, while a noticeable flattening at the poles showed that the little body had once rotated rapidly on its axis, though whether it did so still they had not time to ascertain. When abreast of it, they were less than 2 miles distant, and they secured several instantaneous impressions, which they put aside to develop later. As the radius of Phobos' circle was far shorter than that of the parabolic curve they were making, it began to draw away, and was rapidly left behind. Applying the full apergetic force to Mars and the larger moon, they shot away like an arrow, having had their speed increased by the planet's attraction while approaching it, and subsequently by repulsion. "Either of those," said Bearwarden, looking back at the little satellites, "would be a nice yacht for a man to explore space on. He would also, of course, need a sun to warm him if he wished to go beyond this system, but that would not have to be a large affair. In fact, it might be smaller than the planet, and could revolve about it like a moon." "Though a sun of that size," replied Cortlandt, "might retain its heat for the time you wished to use it, the planet part would be nothing like as comfortable as what we have here, for it would be very difficult to get enough air pressure to breathe on so small a body, since, with its slight gravitation pull, to secure 15 pounds to the square inch, or anything like it, the atmosphere would have to extend thousands of miles into space, so that on a cloudy day you would be in darkness. It would be better, therefore, to have such a sun as you describe, and accompany it in a yacht or private car like this, well stocked with oxygen and provisions. When passing through meteoric swarms or masses of solid matter, collision with which is the most serious risk we run, the car could follow behind its sun instead of revolving around it, and be kept from falling into it by partially reversing the attraction. As the gravitation of so small a sun would be slight, counteracting it for even a considerable time would take but little from the batteries." "There are known to be several unclaimed masses," added Ayrault, "with diameters of a few hundred yards, revolving about the earth inside the orbit of the moon. If in some way 2 of these could be brought into sufficiently violent collision, they would become luminous and answer very well, the increase in bulk as a result of the consolidation and the subsequent heat about serving to bring them to the required size. Whenever the sun showed spots and indications of cooling, it could be made to collide with the solid head of some comet or small asteroid, till its temperature was again right, while if, as a result of these accretions, it became unwieldy, it could be caused to rotate with sufficient rapidity on its axis to split, and we should have 2 suns instead of 1. "Bravo!" said Bearwarden. "There is no limit to what can be done. The idea of our present trip would have seemed more chimerical to people 100 years ago than this new scheme appears now." Thus they sat and talked, or studied maps and istar charts, or the stars themselves, while the hours quickly passed and they shot through space. They had now a straight stretch of over 300 million miles, and had to cross the orbits of innumerable asteroids on the way. The apparent size of the sun had by this time considerably decreased, and the interior of the Callisto was no longer uncomfortably warm. They divided the day into 24 hours from force of habit, and drew the shades tightly during what they considered to be night, while Bearwarden distinguished himself as a cook. This is the end of Chapter 2 in Book 2 of A Journey in Other Worlds. Recording by Tom Weiss.